We've got a great set of sources today to really dig into Red Hat OpenShift. Our our mission is to, get past the marketing deck. We want to get under the hood of its enterprise architecture, what really makes it different, and where it's actually being used.
Exactly. And the main thing the sources point to is that, yes, OpenShift is fundamentally Kubernetes, but that's not the whole story. Its real value is in all the critical layers it adds on top. We're talking integrated security, serious stability, and developer tools that just hide all that underlying complexity.
Okay, so let's unpack that architecture then, because that seems to be where it all starts. We have the control plane, which manages the cluster. But on the worker nodes, where the apps actually run, the sources mention OpenShift uses CRIO specifically. That's not just any container runtime, right?
No, it's a big deal. It's a container engine that's optimized purely for Kubernetes, for security and stability. It's not a general purpose tool.
Hmm.
And this focus on, let's call it governance, extends to how it organizes things. Instead of standard Kubernetes namespaces, it uses what it calls projects.
Projects. Okay,
Yeah.
and that's more than just a name change, I assume.
Oh, absolutely. The critical insight here is that projects are built for multi-tenancy from the ground up. OpenShift basically takes all that complex role-based access control, or RBAC, and pre-makes it right into the project. So resource isolation, team segregation, it's just automatic.
So the key takeaway is complexity abstraction. You're not building all these RBAC policies from scratch. And when you want to expose a service from that project to the outside world, what's the OpenShift answer to something like a complex ingress object?
That's where routes come in. They just make exposing applications so much simpler. A route builds in features that you'd normally need other tools for in Kubernetes, like built-in TLS encryption, load balancing, and domain-based routing. It's all just there.
Okay, so that's great for the platform teams. But the biggest hurdle is often the developer workflow. Is the source-to-image feature, S2I, just some fancy tooling? Or do the sources suggest it's a more fundamental shift in the build process?
It's a workflow accelerator, for sure. Instead of developers wrestling with multi-stage Docker files, OpenShift uses build configs to automate the build straight from their source code. Then image streams manage and track those container images. It just massively speeds up time to market because the platform handles the whole artifact lifecycle.
That efficiency sounds great, but as soon as you step into a regulated industry, like finance or healthcare, security is suddenly job one. How is that tackled by default?
Right, and this is maybe one of OpenShift's strongest points. Security is baked in, not bolted on. The sources really stress security context constraints, or SCCs. These actively prevent containers from running as the root user. That eliminates a massive attack vector before an app is even deployed.
Well, it doesn't stop there, right?
Not at all. You've also got built-in image scanning to find vulnerabilities and really tight network policies to control which pods can talk to each other. It creates a hardened environment right out of the box.
And that hardened environment has to support everything an enterprise throws at it. So it obviously handles your typical stateless web apps, things that scale easily with a horizontal pod autoscaler.
But, critically, it also handles the tough stuff. Stateful applications. We're talking about databases like PostgreSQL, messaging systems like Kafka. Those are managed with persistent volumes, or PVs, which is the platform's way of guaranteeing that storage doesn't just vanish when a pod restarts. It ensures data stability.
Okay, so with all this built in, how are organizations actually using it? What are the big real-world problems this is solving?
The sources highlight two massive use cases. First is enterprise application modernization, taking those old, clunky monoliths and breaking them down into microservices. And second, hybrid and multi-cloud deployments. This is huge. It lets a company run the exact same application consistently across their own data centers,
Wow.
AWS, Azure, you name it. It solves that environment drift problem.
So when it all comes down to it, for the listener, this means getting a consistent platform that cuts down on the administrative headache and just speeds up the whole development lifecycle.
It does, and here's a final thought to leave with. The sources also mention that OpenShift has powerful, specific features for AML and data platforms. It's built to handle things like ML pipelines and GPU-based workloads. This suggests the platform isn't just about today's apps. It's ready for the really intensive computing of the future. So the question is, what new frontiers could you explore if all that complex infrastructure wasn't holding you back?
A complete cloud-native platform, really, designed for the modern enterprise and what's coming next. That wraps our deep dive into OpenShift's architecture and its real-world utility.